Hello and welcome to the video tutorial focused on the Shannon pipeline results page. In this tutorial video, we'll be examining the 4 different results formats generated by the Shannon pipeline and detailing their usage. It's assumed that you've executed the Shannon pipeline on a VCF file that you've uploaded and you'd like to learn more about the results you've been presented with. To arrive at this screen, we've clicked on the View Results of Run link from the View Completed Analyses tab. There are 4 formats in which we can view results. We can download the Shannon pipeline results directly, view tabular output, view scatter plots, or view bed graph tracks on the UCSC genome browser. We'll be examining each of these formats in this video. Let's begin with the subheading Download Pipeline Results. These are results generated by the underlying pipeline code itself without any formatting for the web. Pipeline output can be downloaded in what we call a tidy format, or simply as raw output. Tidy output contains column headers. Decimal numbers are rounded to 2 digits after the decimal point. Strand is represented by plus and minus signs instead of zeros and ones, and columns are rearranged slightly. The format can be used as input for our companion software Veridical, which examines BAM files to determine if evidence is present for the predictions made by the Shannon pipeline. Either filtered or unfiltered output can be downloaded. Unfiltered output will be unaffected by any filters you selected before the run, while filtered output will take them into account. To download any of the files, simply right-click on the link to the appropriate file and choose Save Link As, or the equivalent in your browser. Left-clicking the file will open it in a new tab. This is an example of the tidy output format. Because the tab-delimited files will generally be quite large, it is not recommended that they be viewed within a browser, but instead downloaded and examined using spreadsheet software. If unfiltered output is downloaded, it will need to be filtered in spreadsheet software or another method, but this allows you the freedom to filter pipeline output exactly as you'd like. Let's return to the results page and take a closer look at tabular output. For this example, let's select the cryptic site tab shown here. After clicking the tab, a table will appear similar to this one. Columns can be sorted by clicking on any of the column headers. It can also be searched in real time by entering a search term in the search box located at the upper right of the table. Columns in the table have been grouped together into 6 different subsections in order to keep relevant data together. The first of these subsections is splice site location. These columns contain data related to the splice site itself, or more specifically where it is located in the genome. A second is labeled RI in bits. Here we'll find information on the strength of the splice site both before and after the contribution of the alternate nucleotide or nucleotides. Next we have splice site type and affected gene, followed by dbSNP related data. Cryptic site specific columns appear only when viewing the table within the cryptic site tab. These fields are not applicable to natural sites. Finally, columns in the submitted variant attributes heading describe the attributes of the variant in the VCF file we uploaded. The first 3 columns, labeled chromosome, coordinate, and strand, describe the genomic location of the splice site. Initial RI refers to the binding strength of the splice site in the reference genome. These values are measured in bits, and a higher RI value corresponds to a stronger binding site. After the contribution of the alternate nucleotide or nucleotides is taken into account, we get the final RI value. Delta RI is the change in RI between the initial and final values. A positive delta RI indicates that the site has increased in strength, while a negative delta RI indicates a decrease in binding site strength. Under the type column, sites can be either donors or acceptors. Donors are located at the 5' end of the intron, and acceptors are located at the 3' end. Any genes which are overlapping the variant are listed in the gene name column. RSIDs are determined by examining dbSNP. If no RSID is present in this column, then the variant was not found in dbSNP 135. For those variants which are found in dbSNP, the average heterozygosity is displayed in the following column. A cryptic site in a gene can be found either within an exon or intron. If an indel spans an intron-exon boundary, it is classified as exonic. If a cryptic site is intronic, its location relative to the nearest exon is reported. If a cryptic site is downstream of an exon, it is 3' flanking, otherwise it is 5' flanking. The next two columns report the number of base pairs separating the cryptic site and the nearest natural site, as well as the coordinate of the natural site. Next we can see the RI value of the nearest natural site and whether the final RI of the cryptic site is greater or less than that of the nearest natural site. The final four columns simply report information found in the uploaded VCF file related to the variant. The variant's coordinate, reference and alternate nucleotides, ID, and whether the variant is a single nucleotide variant or an indel. Returning to the results page, let's take a look at one of the scatter plots. For this example, let's examine chromosome X by clicking on the tab labeled X. A plot will be displayed with final RI on the y-axis and coordinate on the x-axis. There are several plot functions I'd like to highlight. First, in order to zoom in, click and hold the right mouse button and draw a box outlining the area you'd like to zoom in on. After releasing the right mouse button, the plot will be zoomed in. Next, if you hover the mouse over a plot point, a tooltip will be displayed containing the ID of the appropriate variant. This ID can be used to find the variant within the tabular data or downloadable pipeline output. To zoom out, we'll make use of the box located to the left of the plot itself. Clicking on the magnifying glass with the arrow pointed to the left will zoom out to the previous level of zoom. Finally, let's upload some bed graph tracks and examine them in the UCSC genome browser. If we click on the View Tracks tab before clicking any of the buttons above it, we'll see that a message is displayed indicating that no tracks have been uploaded. If you've already uploaded tracks from the Shannon pipeline since the last time you closed your browser, you may notice that the tracks are already present. In that case, we should remove those tracks before uploading the new tracks. To do that, click on the button Manage Custom Tracks on the UCSC site and delete the appropriate tracks. Instead of doing that, we could also simply upload new tracks and they will overwrite any tracks previously uploaded from the Shannon pipeline server. This situation is not the case here, however, so let's upload the tracks related to the natural sites by clicking on the button Add Natural Site Delta RI Track and Add Natural Site Final RI Track. The upload process may take a moment depending on how many variants we're dealing with. After the process is complete, the UCSC genome browser will be displayed. After navigating to a genomic coordinate of interest, the uploaded tracks as well as the built-in track ref gene will be visible. Orange bars indicate a splice site with increasing RI, while blue bars indicate decreasing RI. And this brings us to the end of the tutorial. Thank you for watching, and I hope it's helped you to better understand your pipeline results.